Alrighty. Now that we've gone over a little bit about the basics, all right, we're going to go into our notebook now and solve some problems. So let's look at number one here in our pre-calc notebook. It says a sandwich shop offers 4 types of meat: ham, turkey, chicken, and steak. 3 types of bread: white, brown, and wheat. And 2 types of salad: tomato and lettuce. How many choices do customers have for a sandwich using one of each? All right. So we get to choose one of these, and one of these. All right. So that's what we just talked about. Remember, we just talked about the multiplication rule. And the multiplication rule tells us that if we can do the first thing in so many different ways, and let's say the first thing we can do it in X ways, the second thing we can do it in Y ways, then if we want to do both of these things, how many different ways can we do them? X times Y. All right, well, this is the same thing. All right, we have 4 choices for the first thing, 3 choices for the second thing, and 2 choices for the third thing, and we want to do all of these. So the way we can find out how many different ways we can do them all is 4 times 3 times 2, which is 24. All right, so the answer is just 24. All right, so here in our notebook, we're going to write down that rule. So it says the fundamental counting principle. All right, if we have 2 events, we're doing 2 things are going to happen. If one event can occur in m ways and another event can occur in n ways, then the number of ways that both events can occur is going to be m times n ways. All right. And if we have 3 events, then if 3 events can occur in m, n, and p ways, then the number of ways that all 3 can occur is going to be m times n times p. All right, that's what we just used right here. All right, so we're going to use that today. We're going to use that over and over and over again. All right. So let's look here. In a high school, there are 273 freshmen, 291 sophomores, 252 juniors, and 237 seniors. All right. So we would call these 9th graders, 10th graders, 11th graders, and 12th graders. All right. They're going to make a committee, and they're going to pick 1 freshman, 1 sophomore, 1 junior, and 1 senior. How many different ways can they make this committee? How many different ways can they have these 4 people on a committee? All right. Well, since the first thing we're going to do is choose 1 freshman. All right. If we choose 1 freshman, how many different ways can we choose 1 freshman? 273 ways. We could pick this guy, or we could pick that guy, or this girl, or that girl. All right. We can do that 273 ways because there are 273 freshmen. So that's the first thing we're going to do. Then let's pick a sophomore. How many ways can we do that? 291 ways. Then we need to pick a junior. How many different ways can we do that? 252 ways. And then the final thing is we need to pick a senior. And how many ways can we do that? 237. All right. So we do all these together. We just multiply them out. And it'll be a very big number. All right. So I already calculated it out. It's 4 billion. You'll need a calculator to do these. 4,744,653,732. So that's how many different ways that we can pick a committee of 4 students from these individuals. All right. Next, we have a multiple choice question, multiple choice test, like the one we just took last week. Every question has 4 different answers, so A, B, C, D, and there are 10 questions. So then the question here is, how many different ways could you complete the test? All right. So maybe you could do A for all 10 questions, or B, 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 B. Or maybe you go A, B, A, B, A, B, A, B, or A, B, C, D, C, D, A. How many different ways could you do this? All right. Well, the answer is going to be, let's see. How many different ways can we do the first question? 4. Then, how many different ways can we do the second question? 4. How many different answers could we have for the third question? 4. And we keep doing this over and over and over, and we're going to end up with 4 times 4 times 4 times 4. How many times? 10 times, because there are 10 questions, and every one of them has 4 different choices. So what's another way we can write this? 4 to the 10th power, all right? So 4 to the 10th power is going to be the number of ways we could do this. And if you put that into a calculator, you'll see that that's 1,048,576. All right? So that's the number of ways that you can complete a test that has 10 questions and 4 answer choices for each question. All right, next. It says a New York license plate is 3 digits followed by 3 letters. So maybe it could be something like 352 and then G A Q. All right. So that would be a license plate because it has 3 digits, which are numbers, and then 3 letters. So the question here is, how many license plates are possible if digits and letters can be repeated? Means we can use the same one over and over. All right, so we're going to do this by going through each space in the license plate. So let's start here. How many different ways can we put something here? Well, it has to be a digit. All right, which is a number. How many different numbers are there? 1 digit. There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10. 10, all right? 10 different digits, right? 1 through 9 and then 0, all right? So how many ways can we do this? 10. Next, let's go to the next one here. How many different ways can we do that? Well, it has to be a digit again, and there are 10 digits. Then this one. It also has to be a digit, so 10. Then let's look at this one. Well, this needs to be a letter. How many different letters are there? We'll count them, A, B, C, D. If you count them all, there's 26, all right? 26 letters in the English alphabet. All right, then this one also needs to be a letter. So there are 26 different possibilities. And then this one also has to be a letter. So there are 26 possibilities. So this is going to be our answer. And that's going to be equal to, well, that's 10 to the 3rd power times 26 to the 3rd power. And if you put that into a calculator and calculate it out, you get 17,576,000. Okay. So that's our answer. All right. Next, we need to do the same problem again, but this time it says we cannot repeat. All right. What does that mean? Well, let's start again at the beginning. How many different things can we put here? Well, this has to be a digit. And how many digits are there? 10. So it's going to be 10. Then we're going to go here again. to the second one right here. How many digits can we put here? Well, there are 10 digits, but we already used one here, and we can't use the same one again. So how many digits are left? 9. So now we can only use 9 here. Then we go here. How many digits are left for this one? Well, we've already used 2 of them, so there's only 8 left. All right. Then we go to here, and now we need a letter. And how many letters are there? 26. And then we go to the next one, but we cannot repeat the letter, so there are only 25 letters left to use. All right. And then again for the last one, we've already used 2 letters, so there's only 24 letters that are left to use. So then we need to calculate 10 times 9 times 8 times 26 times 25 times 24. And if you put that into a calculator, you'll get 11,232,000. And that's it. Yeah, 232,000. And this makes sense, right? This one's going to be bigger than this one. If we can repeat, that's going to give us more choices, all right? More possibilities, all right? But if we can't repeat, so we're going to have a smaller number. So this is 17 million. This is 11 million, all right? All right, and let's look at the last part. Same type of problem, all right? We need to choose a password, and our password is going to be 5 digits followed by 3 letters. So maybe it could be like 1, 2, 3, 4, 5, and then A, B, C. This is our password. It could be something like this maybe. But we're going to have some restrictions on what we can do. So how many different passwords can we make if letters can only be consonants and digits must be less than 5? And both cannot be repeated, all right? So first of all, we want to know how many consonants are there. Well, consonants are just letters that are not vowels, right? And vowels are A, E, I, O, U, right? There are 5 vowels. There are 26 letters, 5 vowels. So how many consonants are there? 21. All right, so there are 21 consonants. All right, I'll write that down here. 21 consonants. And the other thing, it says digits must be less than 5. All right. How many digits are less than 5? Well, you could have 0, 1, 2, 3, and 4, right? 0, 1, 2, 3, 4. These are the only ones that are less than 5. All right. So there are 5 different ones. All right. So there are 5 digits less than 5. 5 digits that are less than 5. All right. And we cannot repeat. Okay. So let's start. In our first spot, we need to put a digit, and it has to be less than 5. How many different choices do we have? We have 5 different digits that are less than 5. In our next spot, we need another digit that is less than 5. But we've already used 1, and we can't repeat it, so that means we only have 4 left over. Then we need another digit, and we only have 3 left over because we've already used 2. Now we need another digit, and we only have 2 left over. All right. And then finally, we need one more digit, and we only have 1 left because we've already used the others. All right. So 5 times 4 times 3 times 2 times 1. Then we need our letters, and they have to be consonants. Now, the first letter has to be a consonant, and we can pick any consonant, so we have 21. Then the second letter, we cannot repeat, so we only have 20 left. And then the third letter, we cannot repeat again, so we only have 19 left. So to answer this question, we need to do 5 times 4 times 3 times 2 times 1 times 21 times 20 times 19. 5, 4, 3, 2, 21, 20, 19. Yep. And it ends up being 950. So this equals 957,600. That's a comma, not a period. All right, 957,600. All right, so that's how many different passwords we can make. Now, let's look at the last one, B. We need to do the same thing, make a password that looks like this, but now the digits must be an even number. Now, how many even numbers are there? How many even digits are there? Well, 0 is even. 2, 4, 6, 8. All right, 0, 2, 4, 6, 8. So there are 5 even digits. All right, so there are 5 even digits. And then we don't have any, the letters can be any letter. And now we can repeat. All right, we can repeat. All right, so how many digits are there? So let's start with our first digit. How many can we use? 5. Next, we can repeat again. So how many can we put here? 5. We can repeat, so there's 5 left. We can repeat, so there's 5 left. We can repeat, so there's 5 left. Then we need to go to the letters. All right, and how many different letters can we use? Well, we can use any letter, and there are 26 letters. So we can use 26. And then for the next one, we can use 26 again because we can repeat. And for the last one, we can use 26 different letters again because we can repeat. So the answer here is going to be 5 to the 5th power times 26 to the 3rd power. And if you put that into a calculator, you'll get 54,925,000. I think that's right. All right. So that's how you do these problems. I will give you some exercises to do. I don't know if there's, I will look, I haven't looked at the homework book yet. There might not be practice problems like this in the homework book. If there are not, I will give you a PDF attached to the homework. Just look at the assignment and it will tell you what to do. All right. Bye-bye.